Welcome to the screencast for Impact of Trees on Localized Weather. So, this is a project that was created as part of the New York City Parks DataJam this past weekend in June of 2016. So, I'm going to walk through the presentation that we came up with to explain our approach and our project. So here goes. What did we do? We tried to quantify a feeling that I think is pretty familiar to most people, the feeling that you feel better, you feel cooler, and more comfortable under a tree on a hot summer day. So our project aimed to quantify that feeling, and we think it has potentially some implications for how New York City street trees relate to things like the heat island effect, which ultimately could be worsened by climate change and changing weather patterns. So, kind of the major steps involved in this project. First thing we did was we took the street tree data set and merged it with weather data from Weather Underground, and we took average temperature and humidity data from August 2015, and we scraped this data using the Python Beautiful Soup module from 210 weather stations. And out of that 210, taking away a few weather stations that had bad data, we ended up with 2 buckets of weather stations when we merged it with the tree data set. So we had 128 stations whose latitude, longitude put the station close to essentially a street with trees. So they're within 5 meters of at least one tree. Meanwhile, we had a second bucket of weather stations that had no trees. So they were, effectively on streets without trees. Now, these stations, some of them were on the street level, some of them were on top of skyscrapers. They're at various different elevations. And Weather Underground has that elevation listed. So the listing that it gives us is elevation from sea level. So the first thing that we had to do, going to step 2, is we made an elevation adjustment. We pulled in a second New York City open data set called elevation points, which gives you the sea level elevation of basically buildings and street points in New York City. And so for each weather station, we basically pulled in the closest 10 street level elevation points. And the idea behind that is to basically estimate how far the weather stations, can I have 2 minutes? Okay. How far the weather stations are from the street. And then finally, step 3 was to analyze the differences between the weather stations that had trees and did not have trees as a function of elevation. So that's going to make more sense as we go look at the rest of the slides. So scraping from the Weather Underground, this is where we get from each weather station humidity, average temperature, and the latitude, longitude. This is a map of the weather station data overlaid over New York City. And you can see how we've sort of combined it with the tree data set as well. And here is essentially our hypothesis. We've got weather stations near trees, other weather stations not near trees. We would expect no difference between the elevated weather stations with and without trees, simply because we would expect the weather stations to be too high to be affected by any cooling effect that the tree canopy would provide. Meanwhile, we would expect a significant difference between ground stations with or without trees. So here are the results. For temperature, we basically found that there was a difference between weather stations that were under trees and not under trees for weather stations that were below the tree canopy, so low elevation weather stations. up to 4 temperatures, 4 degrees Fahrenheit difference. Meanwhile, if you go higher, and by implication above the tree canopy, we did not find a very big difference between the temperature of weather stations in terms of weather stations near trees and without trees. And that sort of, so essentially we found confirmation of our hypothesis when it comes to temperature. And we also found confirmation of our hypothesis when it comes to humidity. And in this case, somewhere between 3.5 percentage points difference between weather stations that were under trees and weather stations that were not. So take-home message for us is, if you're in the dog days of summer, go under a tree and you can feel up to 15 to 20 degrees Fahrenheit cooler in terms of the heat index that you feel. So that's going to be it for the screencast. Our code's available on GitHub. Please get back to us with any feedback through DevPost or other means. And thank you to the rest of our team. So that's Mattia, Joe, Jordan, and Bob. And this is Nick signing off.